Let's practice. A motorcyclist heading east through the small Lucena city. It accelerates after he passes the signpost marking the city limits. His acceleration is constant and found to be 4 meters per second squared. At time t is equal 0, he is 5 meters east of the signpost, moving east at 15 meters per second. Find his position and velocity at time t is equal to 2 seconds. Where is the motorcyclist when his velocity is 25 meters per second? Solution. Identify and analyze the problem, and if possible make a visible representation of the problem. Upon reading the problem, it tells us that acceleration is constant, so we can use the constant acceleration equations. These are the available information. The acceleration of the motorcycle is constant. This is 4 meters per second squared. The initial position of the motorcyclist away from the signpost is 5 meters. The initial velocity, v sub I, is equal to 15 meters per second. We also have the values of time, t equals 0, and t equals 2 seconds. We also have the value for a final velocity, v sub f, equal to 25 meters per second.
So let's try to solve the problem. Okay, so we are going to list the things that we know about the problem. So we'll start with the acceleration of the motorcycle, and we use a sub x. So this is said to be constant, and it has a value of 4.0 meter per second squared, and we have the value of time. Actually, we have t equals 0 seconds, then t equals 2.0 seconds. And then we have the initial velocity of the motorcycle, so that's gonna be our vi, and that's gonna be 15 meters per second. All right, so we are also asked to locate where is the motorcycle after it moves, or while it is moving with a velocity of 25 meters per second. Alright, so we have seen that this motorcycle is quite capable of such acceleration, because maybe it is a 1000cc motorcycle. So yeah. Alright, so we are trying to look for the position, alright, or distance, okay, away from the signpost, alright, when or after 2 seconds. Okay, so this is the first part, 2 seconds. Alright, so this is not known, so this is our x. Okay, so we have so the signpost is here. Alright, so you can actually draw it. Alright, so let's say for example I have a post here. Alright, so let's quiet the post, and then yeah, and then there is the road right here, and then we have the cycle, and that's the initial velocity. Our initial distance away from the signpost is x sub 1. Let's call that x sub 1, and that's gonna be 5 meters away from the signpost. So this is 5 meters away from the signpost. Yeah, so we put the values there. Then this is actually t equals 0, and then we have the motorcycle here. Yeah, there we go. Then this is a good cycle, so as a person over there. Then at that point it says that the initial velocity is okay, so 15 meters per second, and it has an acceleration of 4.0 meter per second. So that's how we do it, and then it's moving there fast. Okay, so we have some list of formula, so you can check that. So whenever you discuss or you tackle problems like this, you have the list of kinematic equation. So I can say x sub 2. All right, so because I'm looking for um, the position, okay, because time will pass by, and then after quite some time, t will be equal to 2 seconds. All right, 2.0 seconds, and then maybe it's somewhere here at this point if it's on a straight line. All right, and I would like to know how much, all right, okay, how far it is from the signpost. So this one, all right, I'd like to know the total distance traveled. So that's gonna be 5 meters plus this, all right, plus this unknown. Okay, so you have to add this and then you get this total distance traveled. All right, so that's the first part. Okay, we go ahead and look for an equation that can solve that. All right, so I can save this. Okay, so problem solving one. Okay, so if somebody wants the resources, I think I can put it together with the video. Okay, there we go, it's saved. And then um, so I have the formula x sub 2, all right, is equivalent to x sub 1, okay, plus initial velocity times time. Okay, this is the value of time plus 1/2 acceleration along the x-axis times the square of time. So yeah, so I think we have the all the data that we need. So we have a sub x, and that's given, that's 4.0 meter per second squared. And then we have the value of time, and then we are asked to compute for the certain unknown x sub 2. All right, so at a time interval 2 is equal to 2.0 seconds, and then we have the initial velocity vi, and that's 15 meters per second. All right, so we can now substitute it. So x sub 2 is missing, so remain as is. But we have the value of x sub 1, which is um, equal to 5.0. All right, so that's x sub 1 is the initial position, which is 5.0 meters away from the signpost. Oh, that's only meters. All right, so 5.0 meters. Okay, and then we multiply it, substitute the value of velocity, okay, or the v sub I, initial velocity here. So we're gonna have 15 meters per second, all right, times the value of time, which is 2 seconds. All right, so you will see here that this one will cancel out. All right, so the unit will be meters, meters plus meters, so you're arriving at the good answer. All right, plus 1/2, so 1/2 is a constant, so it comes from the derivation, and then we have the value of the acceleration, which is 4.0 meter per second squared. So second squared here is in the denominator, and we have 2 seconds, and then raise that to the power of 2. So s times s is s squared, so you will see that this will cancel out, and then what remains is meters. So you have the same unit, so you can add them all together after simplification process. All right, so we have 5.0 meters plus 15 times 2 is 30, so the unit is meters, plus um, 2 times 2 is 4, okay, times 16, okay, or 2 times 2 is 4, times 4 is 16, divided by 2 is 8, so that's 8 meters. All right, so you add this all together, and oh, why do I have the x sub 2 over there? X sub 2, not x to the power of 2. Okay, x sub 2. Okay, so x sub 2, okay, is now equal to 43 meters away from the signpost. Alright, so we have the x sub 2. We find it, and then by simply using the formula. Alright, so I hope you were able to get the first part of the solution. So this one is 8 meters. Okay, so that's the first part. So let us continue answering our problem, and as you can see, we still have to draw it for so that we can analyze the situation well. So this is the signpost, and it serves as a point of reference. All right, so we're going to draw this. Yeah, so there we go. Then let's assume that it's a straight path. So this is the path, and then the motorcycle it's somewhere right here. So yeah, that's it. And then there's the person. All right, so and it's actually moving with an initial velocity of 15 meters per second. All right, and then it has a constant acceleration towards that direction also, and that's 4.0 meters per second squared. All right, so this is the uh, 5 meters away from the origin, and then after quite some time, all right, this is t equals 0. So this is where this is when we started observing the motorcycle. Then after quite some time, all right, so after 2 seconds, all right, 2.0 seconds, it's here, and we computed that this is actually 43 meters away from the origin. All right, so that's 43 meters. All right, from the signpost up to this point. All right, up to this point. Let's use an arrow. Yeah. All right, I think. Can I? Oh, I cannot invert it. Okay. Anyway, I just use this one. So up to this point. All right, but time passes by. Okay, so we can know the velocity. So first we have to check, okay, if at 2 seconds, um, what will be the velocity? Maybe they have the same answer. All right, but we should check that. Okay, so how do we check that? We have the formula for that, and we must know the final velocity, and that's equal to initial velocity plus, all right, the acceleration times time. All right, so this is bf is equal to bi plus acceleration times time. So we'll check if the velocity here at this point is equivalent to, so that's a question, 25 meters per second. All right, so we do not know, but we have to check. So again, we have to compute for that. Okay, so yeah, so I'm gonna save that. Why not? Because yeah, so I'm gonna use the formula. You have bf right there is equivalent to initial velocity plus the acceleration times time. All right, so we'll check at t equals 2 seconds if bf is equal to 25 meters per second. So if it's not, maybe it's if it's less than 25 meters per second, then it happened in a later time. All right, so there are a bunch of solutions for this. Okay, so we have bf is equivalent to the initial velocity, which is, we know that's 15 meters per second. All right, that's in the given. So plus the acceleration 4.0 meters Alright, per second squared times the value of time, which is 2.0 uh 2.0 second. Alright, so that's gonna cancel out one s there. Alright, so this is 15 meter per second plus 4 times 8, 2 is 8 meters per second. Alright, so at at t equals 2 seconds. Alright, the velocity is only 23 meters per second. So it happened uh, at a time greater than 2 seconds. So that's it. It happened at a time greater than 2 seconds. So basically, the question here is the time. When did it happen? Okay. So when did it happen? When did it became 25 meters per second? Alright, so you're right. We're going to use the same formula in order to find the value of time. Okay, so we need that. So I guess I have to save it again. So this is P 4. Okay, and then so yeah, the question there is a hidden question. So when, okay, so I'm gonna write the hidden question. When did the MC motorcycle ha when did the motorcycle have a velocity of 25 meters per second? Alright, so this is the question. So t is unknown, and we can assume that 25 meters here is our BF. Alright, and we know the value of VI, so we can know we also have the value of acceleration along the x-axis. We just do not know the value of time. Alright, so I'm gonna save that. So that's P5. Okay, so we work on this formula. V sub F, alright, is equivalent to V sub I plus acceleration along the x-axis times the value of time. So we'll solve for t here. So the first thing that you can do is BF. So transpose. So we remove VI here, subtract VI here, and then subtract it to the other side. Alright, so that's equivalent to A sub x times the value of time. Alright, so here we divide both sides by V sub I by A sub x. Alright, so that's gonna be A sub x times time all over A sub x. You will see that this is BF minus BI all over A sub x, and that's another formula that you have to that you can use. Okay, so we'll use this. So this is P6. All right. P6. Okay, so we plug in the values. So for BF, alright, so we write the formula BF minus B sub I all over A sub x, and this is equivalent to the value of time. So this is 25 meters per second, alright, minus 15 meters per second all over 4.0 meters per second squared. Alright, so that's the value of time, and then that's P sub 7. Oh, and then alright, so 25 minus 15 is 10 meters per second all over 4.0 meters per second squared. That's the value of time here. Okay, so the unit would be time is equal to seconds, so that's the unit would be seconds, and then we'll divide this, so this is equivalent to 2.5. Okay, that's 2.5. Alright, so if you want to check for the dimensional analysis, you go ahead, so write the fractions or write the units. Alright, so like here, meter per second to the power of 2 is equivalent to t, so you just have to verify the unit. So this one, multiply the numerator by the denominator and that will become your new numerator. So that is meters times second squared all over. Multiply these two again and this will be your new denominator, and you will see that the unit will be second. So this is t is equivalent to 2.5 seconds. So that happened after quite some time, past 2 seconds, so 2.5 seconds. So we use this value and substitute it into the main formula. So I think this is P8. Save, oh, P7 was lost, so this is P8. Alright, so we go back to this formula. X sub 2 is equivalent to x sub 1 plus Vi times the value of time plus 1/2 ax times t to the power of 2. So x sub 2 is equivalent to the initial position, okay? So that is 5 meters away from the signpost, plus the initial velocity, which is 15 meters per second, and then you have to multiply that by 2.5 seconds, alright? And then you add it to the product of 4.0 meter per second squared, and then that's 2.5 meter, no, 2.5 seconds to the power of 2. So this is 5, okay? Alright, so you know that the unit would be meter. So this is 5.0 meters times 15 times 2.5 is 15 plus 15 plus 0.5 of 15. So let's just multiply it. It's yep, 15 times 2.5 is 37.5, so plus 37.5 meters plus, okay, so this one is 2.5 times 4. Okay, 2.5 times 2.5, square it first, times 4 divided by 2 plus 12.5. So we add all together, so you will see that 12.5 plus 37.5 plus 5 is 55. Alright, so we see that after 2.5 seconds and while the velocity is, the velocity of this particular motorcycle is 25 meters per second, so the motorcycle is 55 meters away from the signpost. Alright, so that's how we deal with this problem. So I hope you learn how to solve problems related to motion in one dimension. Please click the subscribe button, hit the notification bell to learn more from the university. Another solution for part B is when we try to eliminate t from the equation. X sub 2 is equivalent to x sub 1 plus vi times the value of time, so plus 1/2 ax and then times t to the power of 2. So we may want to, since we do not know when the velocity is 25 meters per second, so we do not know the value of time and we want to eliminate this in the equation. So how do we do that? Alright, so first is we remove x sub 1 from this side of the equation, so let's do that. So that's gonna be x sub 2 and then minus x sub 1 is equivalent to x sub 1 minus x sub 1, because we have to subtract it to the other side. We subtract it here, so that's gonna cancel out, plus vi times time, and then you're gonna go ahead and add 1/2 ax, and then times the value of t squared. Alright, so you're gonna have here x sub 2 minus x sub 1 is equivalent to vi times time plus 1/2 a sub x to the power t to the power of 2. Okay, so we can deal with this, but before that, let's multiply both sides of the equation by 2. Alright, so this side of the equation doesn't involve fraction anymore. So when you do that, alright, so it will be multiplied by 2. Okay, so this side also. So it will give you twice x sub 2 minus x sub 1. Alright, so x sub 2 here is the final position. Okay, is equivalent to vi times t. Alright, and then plus 1/2 a sub x times t to the power of 2. So now, where can we get an expression that we can substitute for t? So reminded be reminded that bf is equivalent to vi plus a times t. Okay, so the final velocity is related to the initial velocity and acceleration. Okay, so we can solve for t here, and it will give you bf minus vi all over a is equivalent to t. Alright, so it doesn't involve time here, so this is the expression that we want to substitute, so we can do that. Okay, so we'll substitute bf minus vi all over a sub x for t, and then let's see what we have. Okay, so twice x sub 2 minus x sub 1 is equivalent to twice um, v sub I, or initial velocity, times the value of time, which is bf minus vi all over ax. Alright, so plus we add a sub x, and then bf minus v sub I all over ax, then raise that to the power of 2. So you treat the exponent first. We are going to expand this term and then proceed with the quotient. Okay, so the expansion of that is, let's use this one, bf minus vi times bf minus vi. Alright, so that is the equivalent expression. So this is the equivalent expression of this. The numerator would be, alright, so first this one, so you have bf squared, and then the other one minus bf vi. Alright, so this one minus multiply that one bf vi, and then plus, because negative times negative is positive, vi to the power of 2. Okay, so we will see that the numerator is equivalent to bf squared minus 2 bf vi, okay, plus vi to the power of 2. And then we're going to substitute it here, or yeah. So we write twice x sub 2 minus x sub 1 is now equal to twice, or vi times bf minus vi all over a sub x. Alright, so plus the new numerator that we have, so we have the quantity of, yeah, you multiply that to a sub x, and then we have square this one, so this is ax squared, okay, times bf squared minus 2bf vi plus vi to the power of 2. Okay, so simplify this one. We'll cancel out this, and then we'll arrive at 2 x sub 2 minus x sub 1, alright, is equal to, um, alright, so we distribute, okay, twice df di, okay, so because it's a fraction, I'm gonna write a fraction for that, so 2bf vi, then minus 2vi to the power of 2 all over a sub x. Okay, so plus this one, so you have a sub x, you will see that they are similar, so you can add them together. So you have bf to the power of 2, okay, minus 2bf vi, alright, and then plus vi to the power of 2. Okay, so we have, since they are similar fraction, so you can add, so this one positive and negative cancels out, and then uh, unlike signs, so we subtract them. Okay, so this one, 1 vi will remain, and then this equation will be 2 times x sub 2 minus x sub 1, alright, all over is equal to, yeah, we can add them, so that's a sub x, and then that's bf to the power of 2 minus, we have one remaining b sub I squared here, so we write it here, and then this is our formula. Okay, so from then on we can know the final position, okay, when velocity is equivalent to 25 meters per second. And then we'll try to solve for that. Okay, so we now have 2 times x sub 2 minus x sub 1 is equivalent to vf to the power of 2 minus um, a sub x, minus vi squared all over a sub x. So you can just divide both sides by 2 or multiply both sides by 1/2. Alright, so we'll do that. So this one will cancel out, so you will see that you have x sub 2 minus x sub 1 is equivalent to vf to the power of 2 minus vi to the power of 2 all over 2a sub x. And then you just have to add this to the other side, so you have x sub 2, the final position, is equivalent to x sub 1 plus, alright, that's a fraction, 2ax, 2a sub x, yeah, yes, so yeah, b sub f squared minus b sub I squared all over 2ax. So we'll try this. So that's another equation. You can include it to the equations that we have derived. Okay, so x sub 2 is now equivalent to x sub 1, which is 5.0 meters. Alright, so plus the v sub f is 25 meters per second, or must be 25 meters per second. Alright, so you have to square that. We square that, and then that's minus 15 meters per second, then square, and then all over twice the acceleration, which is 4.0 meter per second squared. Alright, so we have x sub 2 is equivalent to 5.0 meters, so that is equivalent to 25 squared is 625. Okay, yep, so the unit you perform that, so that's gonna be meter squared all over second squared, minus this one is 225, 15 squared, a m squared s squared. So you will see that they have the same unit, so you can subtract them from one another. Alright, so that's 2 times 4 is 8, then meter per second squared. So this will yield x sub 2 is equivalent to 5.0 meters plus. Alright, so we factor out the unit first to show you the dimensional analysis. That's 400 meters squared second squared all over 8 meter per second squared. Alright, so this will cancel out. So we have another meter there. So the unit of this is meters. So this is 400 over 8 is x sub 2, 55. Yeah, so that's 50 meters. So x sub 2 is equal to, okay, x sub 2 is equivalent to 55 meters. Alright, so there we go. So we have completed the solution. I hope you learned something from the university this day.